Hello, everybody. So this one, we do have the NFA right here representation. That is actually the string of ones and zeros, one and zero, where contain at least one and zero substring and end with zero and one. So contain one and zero, so it must be anywhere on one and zero. So that is the minimum requirement and end with zero and one. So that's the um, limitations that we do have in in the particular NFA. So in this kind of we'll begin to just validate the extended transition function using this particular NFA. So let's try to check if this will be acceptable. Could be 0 1 1 0, then 1 1 0 1. So let's try to see that one. To this one. So as what we mentioned earlier, that we'll begin to focus with the delta hat. So delta hat and your Q0, and from empty, it will go to Q0, right? Because there's no input yet, so it will stay in Q0. Now the delta hat function from Q0, wherein your first symbol that you'll begin to process, since you're dealing with delta hat, then WA. So your W is the one, a zero. That's the first input. Where the we'll begin to check the transition of the delta hat earlier. The delta hat of Q0 empty, where we'll find the zero input. And what will be the result for this? The result of Q0 empty is from Q0. So let's try to find from Q0 where input 0 is actually Q0 input 0. It could be going to Q0 still. Okay. Now, delta hat function for Q0 where the input is 0, 1 already, and the transition function of the delta hat Q0 where our input will that will begin to focus. We will check the delta hat of Q0 0 where our new input that will begin to check is 1, and the result for Q00 earlier is still in the Q0. So from Q0 where our input is 1, where will be the transition go? It could be that it's a union of Q0 and Q1. Okay, so that's how it works. And after that, we'll begin to find the 0, 1, 1. Q0, then 0, 1, 1. So from there, we'll begin to check delta hat of Q0, where is 0, 1 and 1. So our result earlier, the Q0 is actually Q0, Q1, and then where, no. That's not how you will organize that one. Should be like this. Q0, then enclose that with this, and Q1, where that is, we'll find the 1, right? So where 4 will be a union. So Q0 to and Q1, that is Q0, which is input 1, that is Q0 and Q1. And union for Q1 and 1 from Q1 1, so that is null. So therefore it is Q0 Q1. Okay, so for this one right now, let's go ahead and check next 0 1 1 0. So the transition function of the delta hat, Q0, then 0, 1, 1, then your new input is 0. Okay, we'll begin to find that. Where the transition function, where is the transition earlier of the delta hat Q0, 0, 1, 1, that is in Q0 and Q1 still. So where our new input is 0. Okay. Now for Q0, where input 0, that will be Q0. And union Q1 input 0 goes to Q2. So therefore, the result will be Q0 and Q2. That's how you work. And let me just do it like this. Okay. Delta hat of Q0, 0, 1, 1, 0, 1. We're done with the transition of the delta hat function of Q0 of 0, 0, 1, 0, where you will begin to find right now the input 1. Okay, so the delta, the transition earlier of Q0, 0, 1, 1, 0 is Q0, Q2, Q2, sorry, and where we'll begin to find input 1 right now. Okay, now, so this is Q0, huh? So Q0 to Q0 and where input 1, where will go from Q0, that is Q0 and Q1 for input 1. Q0 and Q1. It is a concatenation already. And union of from Q2, where input 1, from Q2 input 1, it will stay with Q2. So Q2. So therefore, the result will become Q0, Q1, and Q2. So that's how it works. Afterwards, we'll check the delta hat of Q0, then 0, 1, 1, 0, 1, another 1. Okay, so we're able to finish the delta hat of Q0, 0, 1, 1, 0, 1, and we'll begin to find another 1. So what is the transition of Q0, 0, 1, 1, 0, 1? It is Q0, Q0, Q1, and Q2, and we'll begin to find 1 right now. So this is actually open close parenthesis lang na diha. Now, from Q0 input 1, let's try to see. Q0 input 1, that is Q0 and Q1. So Q0 and Q1. Union will become from Q1 input 1. Q1 input 1 is null. Okay. That is null. Sorry. And union from Q2 input 1. Q2 input 1 will still stay in the Q2. Still in Q2. So therefore, the result will become Q0, Q1, and still Q2 for this one right now. So we're done with 0, 1, 1, 0, 1, 1. We'll find 0 right now. So delta hat function of Q0 and 0, 1, 1, 0, 1, 1, 0. We're able to find earlier the delta hat of Q0, 0, 1, 1, 0, 1, 1, where you will find the input 0 right now. And the result of 0, 1, 1, 0, 1, 1, that is from Q0, Q1, and Q2, where you will find right now the input 0. Okay, there is a comma supposedly here. Okay, so sorry. Now, let's proceed. Q0, input 0. From Q0, input 0, it will go to Q0 only. Q0 only. And, no. Union, since Q1 to 0, Q1 to 0 is pointing to Q2 alone. Q2. And union another. Q2, input 0. Let's try to see. Q2, input 0. It will be Q2 and Q3. So Q2 and Q3. So therefore, the union of that, this is Q0. So Q0, Q2, and Q3. So that's how it works. So the delta hat function earlier, we're able to find the 0, 1, 1, 0, 1, 1, 0, and we will begin to find another 1, the last one. Okay, so the transition of the delta hat of Q0, where we were able to find a 0, 0, 0, 1, 1, 0, 1, 1, 0 or already earlier, and we'll be going to find the input 1 right now. So the transition of this Q0, 0, 1, 1, 0, 1, 1, 0 is actually Q0, Q2, and Q3, where we'll begin to find right now the input 1. We'll evaluate that. So for this here, Q0 to input 1, from Q0 to from Q0 input 1 will go to Q0 and Q1. Q0 and Q1. Now, for Q2 input 1, let's try to see. Q2 input 1, that is Q2, staying to Q2 alone. And union another Q3 input 1, Q3 input 1 go to Q4. Q4. So therefore, the result will become Q0, Q1, Q2, and Q4. Now let's actually validate. This is the final result. Well, let's validate if this is actually accepted in your automaton. So does this end with the final state, which is your final state is Q4? So let's try to see. Yes, we are able to end the Q4. So that means to say this Q0, Q0, I mean the 0110, 1101 is actually acceptable into your non-deterministic finite automaton. So that's actually how it works for this non-deterministic finite automata. Hopefully that you were able to really understand that, and I'll begin to illustrate as well. Through this NFA, we'll begin to illustrate how to convert that into the into the deterministic finite automata also. Thank you so much. And